Thank you for this opportunity to share information with you about our version of a tadpole. No, it's not the cute little critter that eventually turns into a frog, but it's a tool that turns into something that's very useful for conservation, we hope. Over the last several years, we've been working to develop a tag attachment device on a pole that we affectionately refer to as the tadpole. I'd like to recognize my co-authors on this presentation, Michael Moore, Tom Lanigan, and Jason Caput of Woods Hole, and Aaron Barleycorn and Jason Allen of the Sarasota Dolphin Research Program. Since the 1970s, telemetry has provided much information about small cetaceans that couldn't have been learned in any other way. Over the years, the evolving tag designs have been compromises between attempting to minimize the risk of injury to the animal, behavioral changes, drag, mass, and asymmetry on dorsal fins, and thermoregulatory effects in terms of the surface area of the fin that's covered, while attempting to maximize the signal strength, the sensor number and diversity, the range, and the longevity of the transmissions. The tags started out very large and not very effective. Back in the early 70s, we used tags that operated in the CB range that needed to be tracked directly by line of sight. These were huge affairs back in the 70s, and they shrank with the development of VHF technology in the late 70s and going into the 90s and beyond. We were able to use very small transmitters clipped through the trailing edge of the fin in order to be able to keep track of individuals. With the advent of satellite-linked telemetry in the early 90s, we could follow dolphins anywhere in the world from a transmission that went up to a satellite and came back to a receiving station. These early tags were very large and they had many attachment pins in the fin that led to potential for damage. So over the years, we've wanted to try to reduce the potential for damage to the fins while keeping the effectiveness of the tags intact. And so we've worked with colleagues, including Lawrence Howell, to do computational flow dynamics testing of different tag designs, looking at the shape, size, and location on the trailing edge of the fin, the distance from the trailing edge, the antenna and sensor positions. And we've arrived at the current design in the lower left-hand corner here of a satellite-linked transmitter that will tell us where the dolphin is, how deep it's diving, and how long it's been diving. Telemetry application has been limited by attachment considerations. The available techniques for tag attachment have both benefits and drawbacks. The two most common techniques are hands-on catch and release tagging and remotely deployed barbed projectile tags like limpet tags. For the hands-on work, the tags can be secured with minimally invasive attachments. There are risks that exist for the dolphins and the people who are handling them from the capture and handling process. Catch and release can be logistically complex and expensive, and is typically limited to shallow water species or to species for which hoop nets can be used. These attachments can achieve durations of many months. The remotely deployed barbed projectile tags are simpler and less expensive to deploy than the catch and release operations. They can access many species in habitats where shallow water catch and release is not possible, but there remains potential for injury to the dolphin, and typically the attachment durations are less than desired. This information is from Robin Baird with Cascadia Research Collective from limpet tagging that he's done out in Hawaii. Of note here is the pantropical spotted dolphin, which is the closest to the dolphins that we've been able to tag with the tadpole. And in 9 deployments, the median tag duration was 13 days and the maximum tag duration was 21 days. Our thoughts behind developing the tadpole included wanting to be able to tag remotely without capture. This would be for research on species or in situations for which capture would be very challenging or logistically unfeasible. What stimulated this was a trip I made to Patagonia back in 2007 with Pablo Bordino, where we began talking about trying to do research on Commerson's dolphin, a difficult species to work with, but they rode at the bow of the boat quite nicely. Another application would be to tag compromised individuals for further monitoring or while making rescue preparations in order to not lose track of them. And then finally, for stranding response to potentially tag members of large groups that may mass strand or restrand, as in the case of the pilot whales over on the right-hand side here that came ashore 4 times over the course of several weeks. So we wanted to also develop an effective alternative to barbed projectile tags. We wanted to make use of well-tested, off-the-shelf tags, such as those that we've worked with from Wildlife Computers, and we wanted to take advantage of natural tendencies for some dolphins to bow ride and surface at the bow. In this image, we're looking at what marine laboratories really want to know. One of the two does it is use for tadpole control problem. And you can see the interest of the animals in riding at the bow and below the pulpit. So in 2014, discussions began between the Sarasota Dolphin Research Program and staff at Woods Hole Oceanographic Institution, including their veterinarian and engineering staff, that led to the tadpole's conceptual design. And the initial design involved a tag being held in a fixture that pneumatically fires a dart when it's located properly around the fin. In 2017, we obtained funding from Dolphin Quest to move forward with tadpole prototype design and testing, and came up with a design that was useful for field tests after going through some bench testing as well. Basically, the way it works is that the tadpole's V fork, the white plastic that you see on the left-hand side, is placed around the trailing edge of the fin. As it moves farther onto the edge of the fin edge contacts a trigger inside the V. Pneumatic pressure then drives the pusher to push a hollow, sharpened stainless steel attachment pin through an aluminum retaining ring in the right tag wing, then through the fin, coring the fin. The pin is then pushed through a Delrin retaining ring in the left tag wing, and the pusher retracts, leaving the pin and tag on the fin and hopefully bringing back a fin core sample with skin that can be used for genetic testing. This has been an iterative process. It's involved a lot of testing, both in the lab and in the field during 2018 to 23, and testing continues. Began with bench testing on carcass dorsal fins at Woods Hole Oceanographic Institution, followed by field testing of the prototype in Hawaii with the Cascadia Research Collective, and more recently offshore of Sarasota, Florida. Video taken during the test showed the need for speed. There is a rapid response time by the dolphins rolling out of the tool in 30 milliseconds before the tagging is completed. We suspect that this may be an evolutionary response to sharks. The image on the right-hand side shows the peduncle of an adult female dolphin from Sarasota, Florida, and it shows how the teeth of one jaw of the shark were buried in the peduncle, while the others on the other side scraped along the peduncle, presumably as the dolphin rolled out of that shark's mouth. We increased the air pressure and the speed, pushing the engineering limits of the system. The attachment tests during Sarasota Bay health assessments with subsequent monitoring showed us that we needed to change the retaining ring material from magnesium that dissolved too quickly, that corroded too quickly, to aluminum for longer attachment durations. And based on these tests, we had our first successful deployment on an Atlantic spotted dolphin in August of 2023. This is a dolphin Hannah off the bow of the RV Eugenie Clark, moving very slowly and consistently, giving Erin a good chance to get landed. There's an immediate strong response, but she comes back momentarily and rides at the bow of the boat. This is the lower left-hand side picture showing us how well the tag was set on that dorsal fin. Here are some more examples of deployments.
Tag on. Tag on.
So subsequently, we have tagged 7 more Atlantic spotted dolphins for a total of 8. Each dolphin typically has a short-term active response that includes leaping, followed by a return to normal behavior, including bow riding once again. What we've been able to find so far is that the attachment duration appears to be closely related to positioning on the fin. Those tags that are attached with the V up next to the fin as designed stay on the fin longer, transmit longer. Those that are closer to the edge tend to come out more quickly and cease transmitting more quickly. But even with this variation, our median is 38 days for these Atlantic spotted dolphins with a maximum of 89 days. Compare this to the pantropical spotted dolphin that I mentioned before with the limpet tag, where the median was 13 days and a maximum was 21 days. There seems to be good utility to using this technique. Behaviorally, the animals tagged via the tadpole versus those tagged via capture and release are using the same habitats in the same ways. There's no variation between the gold-colored animals caught during catch and release and those tagged with the tadpole in the blue, other than one exceptional dolphin that took a sojourn up to the north following a hurricane. Some considerations for using the tadpole include that it's still very much a work in progress. We continue to try to perfect the tool and the technique. To date, we've only had successfully tagged one species. It's not necessarily a good fit for all dolphins or situations. Bottlenose dolphins have yet to be good candidates off Sarasota. We need to test it with more species at different sites. To date, it's only been done from 2 different boats. We need to try from a variety of vessels with and without pulpits. In order to increase the probability of success, we try to make sure that the bow riding dolphins are surfacing slowly and predictably in the appropriate position and at the appropriate distance below the bow. We like calm seas with minimum vertical movement of the pulpit. We like having a stable tagging platform that is a minimal distance above the water's surface, but doesn't go through the water's surface. A pair of long, strong arms can be very helpful, and experience can be very helpful as well. To date, only 2 people have tagged with this tool. If you think this might be useful for your situation, then send us photos of the potential tagging vessel and the video of your bow riding dolphins, and we can begin discussions. As a bonus, the tadpole has proven to have great conservation value, more than we expected, also with sharks, such as great white sharks and whale sharks. We have a publication on the development of the tadpole that's available, and you can get that through our website over here. We're very grateful to a number of organizations for making the tadpole development possible, including Dolphin Quest, NOAA Restore, the National Marine Mammal Foundation, Mote Scientific Foundation, anonymous donors to Brookfield Zoo Chicago, Cascadia Research Collective, and Dolphin Biology Research Institute. Thank you.